In my previous video, I was eating an apple that was growing in the town of Pripyat, which is just 4 kilometers away from the nuclear power plant, in a highly contaminated place, and most of you people called me crazy for that, eating an apple like this, wanting to induce leukemia and cancer in myself, but is it really like that? Let's put it into perspective. This is a sample of the apple. I put in ethanol to preserve it, and I'm putting that on a gamma spectrometer, high purity germanium detector in a lead castle to shield it from background radiation. And we're gonna do both a qualitative analysis, that is which isotopes are present, but also quantitative analysis, so how much of the isotopes are present. So let's take a look. This is the gamma spectrum of that apple sample, and you can see that we don't really see much as of yet. No significant cesium peaks or anything, but of course we're just measuring for a few seconds now. So let's take a look at that spectrum after 24 hours. This is the spectrum after 24 hours, but it also includes the background. So what one has to do is to measure the empty detector for 24 hours, save that spectrum, then do the analysis of, in this case, the apple, and subtract the 24 hours empty spectrum from that spectrum of the apple. So this is the spectrum after 24 hours with background subtracted, and you can probably only read the numbers on the bottom left if you watch this video in HD and then full screen it, but it says that for this cesium-137 peak we have an activity of 0.63712 becquerel. That is for a 16.5 gram sample. That means that 1 kilogram of the apple has an activity of roughly 39 becquerel. So 39 decays per second from cesium-137 in 1 kilogram of these apples. Now let's actually put that into perspective, shall we? First of all, let's have a look at 1 week worth of morning urine. 1 liter of urine collected in a Marinelli beaker. For this, it's important to know about the biological half-life. The physical half-life of cesium-137 is 30 years. So after 30 years, half of the presented cesium-137 atoms will have decayed. But the biological half-life depends on the excretion rate, in this case the kidneys. Cesium-137 is mostly excreted via the kidneys, so it ends up in your urine. And the biological half-life of cesium-137 is just a few weeks to a couple of months, depending on your metabolism rate. So that's why I actually collected 1 week worth of morning urine, which is highly concentrated and has less water in proportion to other stuff, such as potassium and cesium-137, of course, too. So let's have a look at the gamma spectrum. As I said, the urine sample is 1 liter, so it's pretty much 1 kilogram of urine as well, maybe a little more. And the activity is 0.15 becquerel per liter for cesium-137, which is hardly of statistical significance, as the lead castle and the environment around the detector is slightly contaminated with cesium-137 from previous measurements. So even in this spectrum, which is of course again background subtracted, yeah, it's hardly anything, but okay, you could say 0.15 becquerel per liter of cesium-137 for my urine. In comparison to that, we have the natural potassium isotope K40 in there, which shows up with an activity of 23 becquerel per liter. And well, that's almost a gram, maybe about 0.7 grams of potassium within 1 liter of my urine. Quite a bit of potassium, so maybe I should cut down on eating all those bananas. But I just love them for breakfast, you know. Now let's have a look at this sample of dry mushrooms from Ostersee, which is an area in Bavaria, located over 1,000 kilometers away from the Chernobyl nuclear power plant. And here you can see a cesium-137 peak that is so huge, everything else appears just tiny. For example, the tiny potassium peak to the right, you can barely see it, you can only just see it. Probably would have to put this on logarithmic scale in order to make it stick out. But I'm leaving it on linear scale, so we have a direct comparison to the apple, for example. And you can see that this sample of mushrooms collected over 1,000 kilometers away in the forests of Bavaria in Germany read 215 becquerel of cesium-137. Now, these are dry mushrooms, but you probably also noticed that there's some soil and stuff in there. Mushrooms contain about 90% of water. That would make the sample, if it's dry, roughly about 1 kilogram of mushrooms. But that would be 215 becquerel per kilogram of cesium-137 for the mushrooms. But as there was also some soil and stuff in there, I'd probably say it's double that. So let's say 400 to 500 becquerel per kilogram of cesium-137 for these Bavarian mushrooms. This is not entirely accurate, of course, because of the soil and everything in there, but it should give you a perspective on things. That the apple, 4 kilometers away from the Chernobyl nuclear power plant, is much, much less contaminated than these particular mushrooms collected in the Bavarian forests in Germany. Same isotope, same origin. Now, that's quite interesting, isn't it? Of course, not all mushrooms are that contaminated, but mushrooms in general concentrate cesium-137 to a large extent. Some species less, some more. It depends on the species, but I'm not too good with mushrooms. I can't even tell them apart in the forest, so I can't go into details there. But, wild boar like to consume mushrooms, amongst other things. And when a hunter shoots that boar and wants to put the meat up for sale, he has to bring a sample of the meat to the laboratory to analyze it for cesium-137 content in the first place. And if that boar exceeds 600 becquerel per kilogram for cesium-137, it has to be disposed of as radioactive waste. If it's below that, it is legal for human consumption. So if you go to a nice restaurant now in autumn where the hunters go and shoot some boar, and you just order a nice boar steak from a wild boar, it might just have 500 becquerel per kilogram of cesium-137 from Chernobyl. While if you would consume the same amount of, let's say, apples that you picked right in Pripyat, 4 kilometers away from the nuclear power plant, in a highly contaminated area, you would get a tenth of the exposure than if you were to consume the boar meat. Now think about that. And by the way, don't assume that the boar meat never reaches these limits. Depending on the area, up to a third of all boar meat has to be discarded as radioactive waste as it exceeds those 600 becquerel per kilogram. So you might quite frequently find something that has a few hundred becquerel per kilogram on your plate. But let's also look at a sample of moss from Pripyat, from just where that apple tree is located as well. I'm just dumping it on a random detector without any lead shielding, because that will be sufficient. Can you see that big red peak rising just right off the 500 keV on the scale? You can see it's rising so fast it's easy to tell apart from any amount of background radiation, because this is a huge amount of cesium-137. From the moss just growing next to the tree is not too contaminated, at least the fruit are not, but that moss, wow. But of course I also did that properly, so here's the proper analysis of that moss. You can see the huge cesium-137 peak, and the K40 peak is basically invisible. Maybe 1 pixel if you look right, but it's basically invisible because the activity of cesium-137 is so huge. The activity is 1,781 becquerel just for that small little batch of moss. Now let's just assume that moss is perfectly edible, perfectly suitable for human consumption. Then 1 kilogram of that moss would still have 490 kilobecquerel of cesium-137, which is 490,000 becquerel per kilogram. And I wouldn't recommend eating that moss anymore at all. So you see that you shouldn't really jump to conclusions that fast, because you were giving me shit for eating that apple, like accusing me of being suicidal, saying I would get leukemia or other types of cancer from that. But actually, I guess few of you would have done the same if I collected mushrooms in the forests of Bavaria and made a nice dish out of those, would you? You would have been like, well, what does this have to do with your normal channel content? But you wouldn't be like, you're suicidal, it contains so much cesium from Chernobyl, don't ever eat that. But actually, you would have been in the right much more in regard to the mushrooms from Germany than in regard to this little apple that I collected just at the nuclear power plant, or very close to the nuclear power plant of Chernobyl. So, well, think about that. But yeah, as I said, it really depends. For example, cherries are supposed to contain much more cesium-137 than apples as well. I never found cherries, sadly, but I'd love to analyze those. And If you had a look at the moss, I mean, the moss was terribly contaminated for sure, and I would not recommend eating moss, even if it was edible. I don't know about that, but... So I hope this little video helps you in getting the facts right for the next time, and thank you for watching through until this point.